In the last video, we talked about the basics of arrays. Okay, that they are a contiguous collection of things. They're indexed from 0 to the length minus 1. To get the length, we do the name of the array dot length, and to access an element, we can do the name of the array with the brackets and then the index to get. And we can also use those. We can also use the elements of an array in some expression. Okay. Now, there's one bit of information that we should talk about before we continue, and that is what exactly does new do here? Like, why do we have to have new int on the right hand side? Okay, so first let's get our little diagram. So arrays are what we call heap allocated values. Okay, so unlike primitive values like int, char, double, things like that, arrays are stored on the heap. Now, this should be familiar to you because we talked about the heap before. Where did we talk about the heap? We talked about the heap when we were talking about strings, right? So here's our little heap memory model. And before, I may not have actually said the word heap, but you can think of this as like a segment of memory that is different from where primitive values are stored. Okay? So when we say, like when we type, let's say int a, this is what's called as initializing, or just declaring an array. Okay, so it would be more correct to say that this is only declaring an array, because some people will use the term initializing for something else with arrays. But what this means is that we are declaring space, or rather, we're not declaring space. That's a little disingenuous to say. When we say int bracket bracket a, we are just declaring that a is going to be an array of ints. That's all it means. Right now, this doesn't actually reference anything. There is no array at this point. Okay? So how do we say that a is going to be an array of integers? Well, we can say a is equal to new int and then the size of the array. Okay? This is called instantiating an array. Okay? So anytime you see the new keyword, that means that you are instantiating something called a reference type or an object. Okay? So object I don't want to talk about at this point, but essentially what this operation does in the heap, it says declare 5 spaces, or declare a segment of memory where we can store 5 integers. Okay? So we'll just declare that. And as we know, all places in memory have some address. So we'll just say that this is stored at address A, B, C, D, which is just some location in memory. We don't really care about that. But I just thought I'd throw it in there for the purposes of contextualization. Okay? And when we instantiate the array, all the values are, at least if we're instantiating an array of integers, all of the values are going to be set to 0. Okay, we talked about that in the previous video. Okay, so now there's an array of 5 integers declared on the heap, or in the heap, and a now points to it. Okay, so we talked about this with strings. So a actually just points to a location in memory where the array is stored. Okay, so that's very important to realize. All right. Now, what about when we just first initialize it? What is going on there? Well, right now, A doesn't actually point to anything. At this point in the program, when we just declare an array, it doesn't point to anything at all. Therefore, that means that it points to null, because there's nothing there. That's what null means. It means that nothing exists at that point, or at that particular location. It doesn't reference anything. Okay? So if we try to do something like, let's say right here, if we try to do A at index 2, this will cause a null pointer exception, which just means that we are trying to perform an operation that is technically legal, but it throws a null pointer exception because this array doesn't point to anything. So how can there be an index 2? Well, there can't be. Okay? So those exceptions are pretty easy to avoid, and one of the easiest ways to do that is to, at least with arrays, there are other instances where it might be easier to encounter a null pointer exception, but most people will combine the declaring and instantiating in the same line. And this is what I recommend you do anyway, because there's really no need to separately declare an array like this if we're just writing a method, right? There are instances where this will be very common, but again, we'll talk about that once we get to classes, okay? When we're just writing methods that operate over arrays, there's no need to do, there's no need to create or separately declare an array and then separately instantiate it, okay? Now, what if we want to create an array of strings? So we talked about creating an array of primitive types, and if you want to do it for doubles or chars or booleans, that's all fine. Those all have default values as well. I think double is just 0.0, booleans are false. I don't remember what it is for characters, but they all have default values as well. But what about creating an array of objects? So for example, like a string. A string is an object, right? Well, let's use a different color. Let's say we create an array of strings. We'll call it S. And we'll say S equals new string. And we'll just say that it has 3 strings in the array. Okay? Now, again, what that does is it's going to create a space in memory for 3 strings. Okay? So S is now going to point to that space. Okay? But all of the spots by default, you may think, well, what if they are, like, for strings, maybe they're the empty string? Well, that line of thinking will get you into a little bit of trouble, because that's not what happens. Because, yeah, while that might be a good idea for strings, what would it do for any other type of object? Now, again, we haven't really talked about that, but it's better to say that, like, there's a better alternative, right? It's better to just have all of the objects be null, or all of the entries, all of the elements of the array be null. Okay? So what is this saying? This is saying that S points to or references an array of strings where all of the elements are null. Okay? Now what if we want to assign something there? Well, we can easily do that by saying, like, S at 0 is equal to the string hello. Okay? Now, what this will do, this is actually where it gets a little bit more confusing, is that we're not going to store the string in this space. Okay? What it's going to do, let me do this with a different color actually. This is now going to point to somewhere in memory to the string hello. Okay? So when we have objects, or let's just in this case say just strings, when we have strings, or when we store strings in an array, we're not storing the string itself in the array, but rather we're storing a reference to the string. Okay? So that actually makes it very fast for passing arrays and returning arrays from methods, because if they store let's say we have an array of 100,000 elements, and each, like an array of strings of 100,000 elements, okay? And all of the elements were populated with random strings, okay? If we had to return that or pass that to a method, then it would have to copy all of those strings between each method, okay? And that would be very slow. So when we pass arrays and return arrays from methods, we're actually doing something called is something that I like to call pass by pseudo reference. Okay? So what this really means is when we have a method, let's say we have the method static int foo, and it receives an array of strings. Okay? An array of strings. So let's expand this a little bit. There we go. So when we call this method, like let's say, let's scroll down a little bit more. Let's say we call this with some, like let's say we pass this string into the method. Okay? So what Java is going to do is it's not going to pass the array itself. Rather, it's going to pass a reference to that array. So inside of this method, when we pass the array to the method, we're actually just passing a reference to that array. So that means, for example, if we mutate the array inside of this method, like this, and just let's say just return 0. If we do that inside of this method, then the outer array is going to be changed as well. Okay? Now, you may be wondering, why is this called pass by pseudo reference? And that's just because Java is actually what's called pass by value. And if you know what that means, then great. If not, it just means that all values are copied into a method. But the thing is, I just said that arrays won't be copied, we'll pass a reference. And that's true. So then you may say, well, is Java pass by reference for certain things? And the answer is no, it's still pass by value. But what happens is, when you pass a reference to a method, you're actually passing a copy of the reference. So it's like we create a copy. So let's say that this array is stored at address 0x ff, and when we call foo with s, we're passing the number 0xff. Okay, and that value is passed by value. Okay, so what that means is, if we then change what s points to inside of this method, then the original reference won't change. So if we do s equals new string of 10, the original string, this array is not lost. Okay, this s still points to the original array. Okay, in the next video we'll do some live coding examples to really drill in what this means. Okay, and then after that we'll finally get into actually using arrays in methods.